Okay, so we have in this chapter we have talked more about the prime numbers. We have given the Euclid theorem that said that there are infinitely many primes. We have proved it by contradiction. Uh, we have gave some comments that can we have a formula to find out the prime numbers up to n, and then we gave the conjecture by Gauss, which says that the ratio of the numbers of primes up to n and this expression should get closer to 1 as n gets larger and larger. So, but like Gauss was not able to prove it, but these two guys have proved it and gave it became a theorem in 1896. Then we talked about the Goldbach conjecture and the twin prime conjectures. Now, the book we are studying at this time is one second. So, the book we are doing is Martin Liebeck, and then there is a conjecture by Martin Liebeck for the primes that the only triplet of primes of the form p plus 2, p plus 4 is 3, 5, and 7. And it is simple. So we say that one of these three numbers p plus 2, comma p plus 4 must divide by 3, must be divisible by 3. Okay, since they are all primes and one of them must therefore be equal to 3. So the only possibility is p is 3. Okay, perfect. Now we have this one. For the positive integer n, define phi of n to be the number of positive integers a less than n, such that a and n are co-primes to each other. So for example, phi of 2 is 1, phi of 3 is 2, phi of 4 is 2. Okay, 1 second. The only thing which I want to make sure is phi of 4 is 2. Okay, now let's solve this. So let's say for n is 5, 6, 7, 8, 9, 10, we have phi of n equals to 4, 2, 6, 4, 6, 4, respectively. So if P is a prime, then all the numbers 1, 2, dash, dash, up to P minus 1 are coprime to P, and hence phi of P is P minus 1. Now, for r greater than or equal to 1, the numbers between 1 and P power r, which are not coprime to P power r, are those which are divisible by P, namely the numbers Kp with 1 less than or equal to k, k less than or equal to P power r minus 1. There are P power r minus 1 such numbers. And hence phi of P power r is nothing but P power r minus P power r minus 1. Okay, perfect. Then there has been quite a bit of work over the years on trying to find a nice formula that takes many prime values. For example, x square plus x plus 41 is prime for all the integers x, such that minus 40 is less than or equal to x, x is less than or equal x is less than 40. You may like to check this. However, find an integer x coprime to 41 such that this is not prime. So that will be that solution is just a single line. So x is equals to 40 will do nicely. How? So let's say 40 square plus 40 plus 41 is going to be 1600 plus 40 plus 41, and that is going to be 1681. And this is not a prime. Why? Because this one is divisible by 3, I think. So if you divide 681 by 3, so over here 5 times, pass 1, you will have 18 or 81. Not with find. You can divide it by the number, let's see, 1681 divisible by 3, no. 7, no. 9, no. 11, no. 13, no. 15, no. 17, no. But it's not prime. 1681 divisible by 3, 5, 7. So you will find it. You'll find some number. This is not prime. 1681 is prime or not. $41. So you can divide it by 41. Yes. So you can divide it by 41. One time, 41 times. So you can say 41 times 41 is 41. 1681. Okay. Perfect. So here we will end this, and then we'll talk about the next chapter in the next video.